Hello dear students, I am Ronak Kumar, your physics faculty at Aakash BYJU'S, and today we are going to discuss the quick video solutions for AIATS 2024 RM Test 4 Code E that will be conducted on 18th of February 2024. Now let us move towards our first question for the section A. So in the first question we have been given that an accurate Celsius thermometer and faulty Fahrenheit thermometer reads 60 degrees Celsius and 141 degree Fahrenheit respectively when placed in the same bath. The error in Fahrenheit thermometer will be. Dear students, we know the relation between the Celsius scale and the Fahrenheit scale. C by 100, that is equal to F minus 32 over 180. Now, according to the question, the reading of the Celsius scale is right. That means that let us put in place of C, I'll put 60. So 60 by 100, it is equal to F minus 32 over 180. Right now, as you solve this, the value of F is coming out to be equal to 140 degree Fahrenheit, right? 140 degree Fahrenheit. So that means that the correct reading corresponding to 60 degrees Celsius on the Celsius thermometer will be 140 degree Fahrenheit, but the faulty reading is 141 degree Fahrenheit. So the error will be equal to 141 degree minus 140 degree, that is equal to 1 degree Fahrenheit, and it is given to us in option 3, which has been verified by the answer slide as well. Okay, moving forward to question number 2. Two steel rods have length in the ratio of 2:3 are heated from 30 degrees Celsius to 60 degrees Celsius. The ratio of their linear expansion is. Dear students, we all know that linear expansion delta L, it is equal to L1 alpha 1 delta T. L1 is the initial length, alpha 1 is the coefficient of thermal expansion, delta T is the change of the temperature that is taking place. Okay, so we need to find the ratio of their linear expansion, right? So I can write delta L1 over delta L2 to be equal to L1 alpha delta T. In place of delta T, I can write the change is of 30 degrees Celsius, so I can write it to be equal to 30, right? And in place of for the second rod, length is L2, the coefficient of thermal expansion will be alpha only because the material is same, that is both are made up of steel. Okay, so L2 into alpha, again temperature difference remaining same, so the ratio is coming out to be equal to L1 by L2, that is also equal to 2 upon 3 as per the data given in the question. So the correct answer becomes the option 1, which has been verified by the answer slide as well. Okay, now moving forward to question number 3. Heat transfer by the bulk movement of molecules within fluid occur due to. So the heat transfer which occurs due to bulk movement of molecules within a fluid is known as convection, right? So the correct answer to this question becomes the option 4, and it has been verified by the answer slide as well. Okay, moving on to question number 4. The transverse wave represented by the equation y, that is equal to 4 sine pi by 6 into sine of 3x minus 15t. X is in meter and t is in second. So we need to choose the correct options, and in the options we have amplitude, wavelength, speed of propagation and time period. Let us approach this question. Okay, so the amplitude over here is 4 sine pi by 6, right? So let us solve this. So amplitude becomes 4 into sine pi by 6 is 1 over 2. So 4 into 1 over 2, that is equal to 2 meter. So the amplitude is 2 meter, but it is given 4 meter. Option 1 will be wrong. Let us talk about the option number 2. So we have the value of 2 pi by lambda to be equal to 3. That means lambda is equal to 2 pi by 3 meter. Again, it is given 4 pi by 3 meter. Wrong. Speed of propagation. Speed of propagation can be found out V, that is equal to omega over k. The value of omega is 15. The value of k is 3, so it is coming out to be equal to 5 meter per second. That means this one is right. Let us talk about the time period. So we have omega to be equal to 15, that is equal to 2 pi over t, right? So t is coming out to be equal to 2 pi by 15. Again, this one is wrong. The correct answer should be the option 3, which has been verified by the answer slide as well. Okay, moving on to question number 5. Two rods of same length and diameter having thermal conductivity is 2K and 4K are joined in parallel. The equivalent thermal conductivity of the combination is. Let us assume that the equivalent rod that we are whose thermal conductivity we are going to find, it will have an area of 2a, considering both the rods will have area of cross section to be a and its length to be L, right, and its thermal conductivity to be equal to K effective. Now the rate of heat flow through this rod should be equal to the sum of rate of heat flow through both these rods. So I can write K effective into 2a into delta T over L, right. This is the rate of heat transfer through the equivalent rod. It should be equal to the rate of heat transfer through both these rods, that is 2k into a into delta T by L plus 4k into a into delta T over L. Now since they are connected in parallel, the temperature difference will be same, right. So this temperature gradient term will cancel, this a and a will cancel, right. So we have 2k effective to be equal to 2k plus 4k, that is 6k. So k effective from here is coming out to be equal to 3k, which is given to us in option 2, right. Let us verify this with the answer slide. So yes, the correct answer to this question becomes the option